Okay, I want to start talking about how we can apply this idea of exponential growth to the real world. Well, one way we can apply it is with interest. We use interest all the time, compound interest. For example, mortgages use compound interest. If you ever buy a car, you're going to use compound interest. If you want to retire, if we didn't have compound interest, you couldn't even retire. Well, you might be able to, but not as likely. You need that compound interest to grow your nest egg. So let's talk about what a compound interest formula might look like and how we can use that to see how we would find an investment over time. Well, let's look at this compound interest formula right here. Here we have the compound interest formula, and this A of t represents the total amount of your investment. That's how much money you're going to have after 20 years. That's what the price is going to be, or how much you have at 20 years. And let's say this P here represents the principal. And what the principal is how much money you actually put into this investment at the beginning. So let's say I had $5,000. I wanted to put it in a fund for my son. I'd put that $5,000 in there. What is this? Do you want to change the color scheme to improve your... No, I don't want to do that. Oh, gosh. Okay, so then we have this R right here. This R represents the rate. So when you invest this money in a rate for Levi, what they're going to say is, well, we'll give you 5% a year. And that's what that R is, 5% per year. Then we have this T right here. This T represents the time in years that you're going to be invested. So Levi's not going to be graduating for 18 years, and so if I put something in his college fund, that T would be 18. So that would be that. And then this N represents the number of times interest is compounded per year. So sometimes things are compounded semi-annually, which means it's compounded twice a year. Sometimes it's compounded daily, which is crazy. That's compounded every day. That's 365. Maybe it's compounded monthly. If it's compounded monthly, your N would be 12. So that's what that N represents. Let's see how we can apply this to the problem right below.